let's solve another problem. And what we have here is that there's an astronaut who is stranded from his spacecraft, and this is the deck of the spacecraft, and the mass of the astronaut is 80 kilograms. Now the problem is he has just 15 seconds of oxygen remaining. Well, so let's say 10 seconds of oxygen remaining, and he is 100 meters away from the deck. But fortunately, he has a small, let's say, mass which weighs 10 kilograms. So what he can do is throw the mass in this direction, and because of that he will recoil back and reach to the deck in time. The question is, with what velocity should he throw this particular mass so that he reaches the deck in time, right? Okay, so let's see what happens. Initially, what is the momentum? What is the total momentum of the system? Let's say this is the ball. The initial total momentum of the system is 0. No one is moving, neither the ball, neither the mass, nor the astronaut. But when he throws the ball or the mass in one direction, let's say with the velocity v, he is recoiled towards the deck, let's say with a velocity capital V. Let's call this the x-axis. So this is the final situation. What is the net momentum in the final situation? Well, it's going to be 10 v, where 10 is the mass of the ball and v is the velocity of the ball, and it's pointed in the x direction, minus 16, well, not 16, minus 80 capital V equals 0, because still the net mass of the whole net momentum of the whole system is 0, and that gives us V equals well, capital V equals 1/8 small v. Okay, alright. So he is moving towards the deck with a velocity v/8. The ball has been thrown away with the velocity v. But then the question is, he has to travel 100 meters with this velocity in time 10 seconds. So what should be the velocity so that he is able to do that? Which means v/8 multiplied by 10 equals 100, right? And that should give us v equals 80 meters per second. This is a lot of velocity. Probably astronaut will never make. So that's a lot of velocity. A human being really cannot throw a ball with this velocity. So if you feel compassionate about the astronaut, you can reduce the weight.